In this video, we're going to look at problem number 87 from lesson 6.1. Here it says an amusement company maintains the records for each video game it installs in an arcade. Suppose that C of X and R of X represent the total accumulated costs and revenues in thousands of dollars, respectively, T years after a particular game has been installed. If C prime of X is 2 and R prime of X is 9e to the negative 0.03t, then find the area between the graphs over the interval on the x-axis from 0 to the useful life of the game and interpret the results. So let's look at the graph of this. I tried saying this is C equals 2, but it wouldn't graph it, so we have to go Y equals 2. And here's the graph of the revenue function. You can see our revenue function is a decreasing exponential function, so it's exponential decay. And Y equals 2 is this line here, 2. Now remember, the Y values here represent, did it say thousands of dollars? Thousands of dollars, so that's like $2,000. Anyway, it told us specifically in the directions to find the area between these two for the useful life of the game. Well, the useful life of the game is going to end when the cost, which is my red function, does exceed the revenue. So that's when X is 5.014. So we are going to be integrating the difference between these two functions from 0 to 5.014. You can see that the E function, my revenue function, from 0 to 5.014 has the higher Y values, so it will go first in our integration. Let's write this on our notes. Here we have the integration that we want to perform from 0 to 5.014 of 9e to the negative 0.03t minus 2, and we're integrating that with respect to dt. Now, this blue part isn't really a part of our integration. It's just telling us which variable to integrate with respect to. When we need to integrate this, we need to remember how to integrate e. So for integrating e, what you do is e to the t just becomes e to the t because this is understood to be a 1. And if you take the derivative of the exponent, you get a 1, and we'd be dividing by it. So if I were integrating e to the 2t, it would become e to the 2t, but then divided by the derivative of your exponent, which would be 2. Integrating e to the 0.05t would become e to the 0.05t divided by 0.05. And e to the negative t, if we integrated it, would become e to the negative t divided by negative 1. Now, let's do that here. If we want to integrate this, therefore, we're going to get 9e to the negative 0.03t, and we divide that by a negative 0.03. If we integrate 2t, or 2, we're going to get 2t. And we want to evaluate this between 0 and 5.014. Since we have a definite integral, we don't have to add that plus c because we have bounds of integration that are given. We can clean this up. If you take 9 and divide it by negative 0.03, you're going to get 300. This is actually, if you wanted to clean that up, 9 divided by negative 0.03 is a negative 300. E to the negative. Did I write that right? I didn't. I didn't write that right. This is not 0.03. You'll have to excuse me. This is a negative 0.3. That 0 shouldn't be there. So when we divide this, we should actually get a negative 30. Excuse me. So we're going to get a negative 30 e to the negative 0.3t minus 2t evaluated from 0 to 5.014. Let's plug that in and see what we get. substituting those values in, this first parentheses will give us a negative 16.69 and some change. And then back here, when you take e to the 0 power, this part of this expression equals 1. So a negative 30 times 1 is a negative 30. This, of course, is 0. But subtracting a negative 30 means add. So when you take the negative 16 and add the 30, you get 13.30615. But then we need to remember that this is in thousands of dollars. So that's really $13,306. Anyway, thanks for watching. Hope that made sense.